With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So the question is, a clock pendulum made of invar has a period of 2 seconds at 20 degrees centigrade. If the clock is used in a climate where average temperature is 40 degrees centigrade, what correction in seconds may be necessary at the end of 10 days to the time given by the clock? And alpha of invar, that is the linear expansion coefficient for invar, is given as 7 into 10 to the power minus 7 per degree centigrade. And in 1 day, number of seconds is given as 8.64 into 10 to the power 4 second, and alpha of invar is given as 7 into 10 to the power minus 7. Now we know that time period of a clock pendulum is given by T equals to 2 pi under root L upon G, where L is the length and G is the acceleration due to gravity. So now temperature is changing from 20 degrees centigrade to 40 degrees centigrade. That means there is change in linear expansion takes place, and because of that linear expansion, length is changing. So that means if I write T dash at this is at 20 degrees centigrade, and if I write T dash at 40 degrees centigrade, then it will be 2 pi under root delta L upon G, delta L upon G. This is for 40 degrees centigrade. Now, if I calculate the change in pendulum, change in time period, that is delta T upon T. Delta T upon T, if I write, suppose this is my equation 1 at 20 degrees centigrade, and this is my equation 2 at 40 degrees centigrade. Now, if I calculate the value of delta T upon T, delta T is change in time period, that is T dash minus T upon T. If I calculate T dash minus T upon T, then the value will be coming out to be half delta L upon L. Okay, so this is the value. Now we know that linear expansion equation is given by change in length, that is delta L equals to L alpha delta T. This is the linear expansion equation. Alpha is the coefficient of linear expansion. Delta T is the change in temperature. Suppose I write delta theta because T is here for time period. So for change in temperature, I will write delta theta. Delta theta is the change in temperature. Alpha is the coefficient of linear expansion. L is the original length and delta L is the change in length. So this is the equation of linear expansion. So I will put delta L as L alpha delta T. So the value of delta T upon T, that is equals to half L alpha delta theta upon L. L cancel out. So from here, delta T upon T will be half alpha delta theta. Okay. Now we have to calculate the value of delta T, change in time period. So I will write change in period delta T, that is equals to T by 2. Okay, T by 2 alpha delta theta. Now we have all the values. Time period at 20 degrees centigrade, value of alpha and delta theta. So putting all the values, we will have delta T, that is equals to time period is 10 days. So in 10 days, number of seconds in 1 day is 8.64 into 10 to the power 4. I will change 10 days into the second, okay, because 1 day is having the seconds 8.64 into 10 to the power 4 second. So that means 10 days are having seconds 10 into 8.64 into 10 to the power 4. This is the value of time period. Into alpha. Alpha is given as 7 into 10 to the power minus 7. And delta theta. Delta theta is the change in temperature. At initially temperature is 20 degrees centigrade and final temperature is 40. So change in temperature is 40 minus 20, that is 20 divided by 2. After simplifying this, we will having delta T, that is coming out to be 6 seconds. This is the change in time period when we increase the temperature from 20 degrees centigrade to 40 degrees centigrade. Okay. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.